Good afternoon, boys and girls. Today we're going to be looking at lessons 19 and 20 of Module 5. For those of you who are already past this, great job. For those of you who need a review on it, watch this video. If you're not up to this point yet, don't rush. Just do the best you can. So let's look at the directions first. It says use the RDW process to solve. That is something we've been doing all year inside the classroom, so you should be familiar with that. RDW stands for read, draw, write, and when you see that, you know that we are going to be doing word problems. Okay, so let's look at question 1, and then I'm just going to skip down to question 3. This is still the topic of adding and subtracting fractions with denominators that are the same. And you're going to see once I get into lesson 20, we're going to be adding and subtracting fractions with denominators that are different. So you'll see when we get to the next lesson, we'll have to make sure that we do something to those fractions to make sure that the denominators are the same, because if the denominators are not the same, you cannot go and add and subtract. We talked about that in our last lessons. So let's look at question 1 before we get ahead of ourselves. I'm going to read the question out loud. It says, Sue ran 9/10 of a mile on Monday and 7/10 of a mile on Tuesday. How many miles did Sue run in the 2 days? So they gave you a huge hint right there. So first you got to figure out, am I adding or subtracting? Well, there's a big hint in this question. It says, how many miles did Sue run in the 2 days? So what do we have to do with these two fractions of 9/10 and 7/10? Well, at home you should already have it in your brain. We are going to add, and the reason for that is because it's asking us for the total of those 2 days, Monday and Tuesday. So I have Monday here, which is 9/10, and I have Tuesday here, which is 7/10. Now, if you wanted to draw a picture, you could draw 2 tape diagrams, or if you want to draw a number sentence, you should have this written on your page, okay? And what's nice about this problem is the denominators are the same. We're using the same fractional units here, so we don't have to do anything to it. We just need to add 9/10 and 7/10 is, well, what's 9 plus 7? We're going to leave the unit of tenths. 9 plus 7, that should be an easy one, 16. Can we leave our answer like this, 16/10? Think about last lesson. Nope. We're going to number bond it. We're going to pull out the whole and rewrite it as a mixed number. So we're dealing with tenths. So how many tenths make up a whole? Well, 10. So I have one whole, and how many are left over? How many more to get to 16? 10, and 6 more gets me 16. So I have... You would have to write it as a sentence now because this is a word problem. Sue ran 1 and 6/10 of a mile in both days. I can't fit it over there, but in both days is what you would have wrote. So Sue ran 1 and 6/10 of a mile in both days. So she didn't run 2 full miles, but she ran more than 1 whole mile. So that's where this makes it way easier to read 1 and 6/10 than 16/10 of a mile. No one talks like that. You would say, I ran 1 mile and 6/10 of a mile. Okay? So that is question 1. Let's jump down to question 3. And for question 3, I'll show you how to do it if you were to draw a picture instead of a number sentence, and I'll also do the number sentence. So question 3 says, Maria spent 4/7 of her money on a book and saved the rest. What fraction of her money did Maria save? Well, if she spent 4/7 of her money and saved the rest, what operation do I need to solve this? If she's spending something, is the number going to get bigger or is it going to get smaller if you're spending something? If you said smaller at home, you are correct. So you have 4/7 of her money she spent. So I'm going to draw a tape diagram and I'm going to cut it into sevenths because that is the easiest way to do this. So 1, 2, 3, 4, 5, 6 lines going down. We'll make sevenths. And I'm going to shade in how much money she spent on the pocketbook. So from here to here is 1 whole, or 7 sevenths, because it doesn't say that she has more than a whole. She only has one thing. Okay? So she spent 4 sevenths. 1, 2, 3, 4. Well, how many sevenths does she have left that she saved? 1, 2, 3. Okay? So as a number sentence, well, as a statement, you would write, she saved 3 sevenths of her money. If you're like me, I would have wrote this as a number sentence, and I would have done 7 sevenths minus 1, 2, 3, 4 sevenths equals 3 sevenths. So that's how you could use a picture. And that's also how you could use a number sentence, but you need to make sure that when you are done, you write a statement. Okay? That's all I'm going to do for this lesson, because it's very repetitive. It doesn't get too complex for these word problems. So the biggest thing for these word problems are that you're reading each question and you are deciding whether you are going to be adding or subtracting using the hints in the question. So you got to think, well, what do they want me to do? Your next step would be to either draw a picture or a number sentence, and then your last step always is to write a statement, okay? So it's 3 steps. Read it, draw it, write it out. Okay, let's go to lesson 20. This is where things get a little bit trickier. This is what I was telling you that we're going to get into, where it says use a tape diagram to represent each add-in. So we're going to be adding. Decompose one of the tape diagrams to make like units. So we're going to break up one of the tape diagrams to show an equivalent fraction. And the reason why you're going to do that is because these denominators are going to be different. And like I've been saying, you cannot add a fourth to an eighth. It's impossible. You need to make them the same unit. And to do that, you need to list out multiples. And I'm going to show you how to do that in a minute. Okay? You need to figure out how you can make the denominators the same. Okay, then write the complete number sentence. Part A is partially done for you. So I'll show you what they have on part A. They have 2 tape diagrams. One's broken into fourths. And then there's a dotted line. But I want to show you it as fourths first before they just show you the dotted line, so you see what they're doing. One's already done into eighths for you. Okay? One, two, three, four, five, six, seven. Oops, I forgot a box. That's what I was checking. 8. So see, even sometimes I make mistakes, so I had to double check my work. So what I want to show you is they have 1/4 plus 1/8 equals, okay? You cannot just go down here and go 1 plus 1 is 2, 4 plus 8 is 12, 2 twelfths. No, makes no sense, okay? That does not make any sense. Your denominators need to be the same. Okay, so this is supposed to say a fourth. So what they're showing you, what they're going to do is they're going to show equivalent fractions. Well, how many eighths equal up 1/4? And this is why you can't just add them. This chunk is 1/8. So how many eighths make up a fourth? Well, look at your tape diagram. They break this one up to make eighths. And the equivalent fraction is, well, how many eighths do you have? You have 1/8 and another eighth, so you have 2/8. So 1/4 is the same as 2/8. That's why you can't just add them. So then what you're doing is you're taking 2/8, adding 1/8, and you get how many eighths? You got 1, 2, 3. So 1/4 plus 1/8 is really 2/8 plus 1/8, which is 3/8. Okay, let me show you an easier way to do it, because they get crazy with showing you why we're changing it. So I'm going to show you the same problem, 1/4 and 1/8. Okay, when you're adding fractions that have denominators that are not the same, you need to make these denominators the same by finding the smallest common denominator, the smallest common factor. We were doing this with division, okay? So let's find, sorry, I'm trying to get it so that doing my best I can so that that sun's not hitting the board. 1/4 plus 1/8. So what you need to find is, you need to look at these bottom numbers and you need to say, okay, what is a common denominator that we can make that both 4 and 8 go into? Well, to do that, you get your factor tree over here. And you want to see, well, 1 times 4, 2 times 2, okay, 1 times 8, 2 times 4, okay. Wait, I'm doing this wrong. I'm doing the division way. I'm sorry, scratch that. What you want to do is see, can you multiply something by 4 to get to 8? You want to list out your multiples. So, my bad, you go to the smallest fraction and you list out your multiples of 4 until you get to 8. And that's going to show you what you're going to multiply this fraction by to make it into a common denominator. I was doing a lesson that was before. I'm sorry if I confused you. Scratch what I said before. So, listen to me now. You are going to take your 4s and you're going to list out your denominators until you get to 8, okay? So you have 4, 8. And then if you watch Mrs. Cott or my videos earlier, you will see that what she showed was a cool trick, and you list out how many steps you took, because that shows you what you multiply. So 1 multiple, 2 multiples, so you're going to multiply by what? 2. Whatever you do to the top, you need to do to the bottom. So 1 times 2 is 2. 4 times 2 is 8. So now it is the equivalent fraction of 2/8 plus 1/8 equals 3/8. Okay? Since I totally confused you before, look at B, and I will show you exactly what I'm talking about with this one. So B shows we still stick into the fourths, and I'll show you with the tape diagram too. You're doing 1/4 and 1/12. Well, right away you should be able to look at these fractions and say, well, I can't add these because a fourth is way bigger than a 12. If I took a whole pizza and I cut it into 4 pieces, those slices are going to be big. If I took it and cut it into 12 pieces, the same whole, those slices are going to be tiny. So you can't take a fourth and add it to one of those 12s. It doesn't make sense. What you need to do is convert the big fractional unit into the smaller fractional units, the easiest way to do it. And we're going to make these fourths into 12ths. And what you're going to do is you're going to list out your 4s until you get to 12, not as close as possible. You're going to get to 12. So list out your 4s, and you're going to go 4, 8, 12. Well, what am I going to cut these fourths into? How many multiples did you list? How many multiples did you list? 1, 2, 3. So you're going to take this fourth, and you're going to multiply it by 3/3. Okay? 1 times 3 is 3. 4 times 3 is 12. So 3/12 plus 1/12 equals 4/12. That is the simplest way to do it. Now, I'll show you what also they want you to do on your boards is they want you to show it using a tape diagram. Well, 2 separate tape diagrams. They want you to start with the fourth. And I'll have one already made up of the 12ths. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I have my fourths. I got my 12ths. We have 1/12. Just want to make this a little and 1/4. If you look at the slices, you can tell that fourth is way bigger than that 1/12. Okay? So what we're going to do is you're going to cut it into those thirds like we just did to get to 12. So 1, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So now you have the 12 slivers, and I'm doing my best. I don't have the best whiteboard like I would be doing in class. 1/4 is the same as 3/12, and you can see that by doing 1/4 times 3/3 gives you 3/12. 3/12 plus 1/12 is 4/12. This is what I just did, but this one is showing it with a picture, okay? So that is what you're doing for this lesson. So I'm going to go over E with you and F, and the rest I want you to do on your own. So let's look at E. We have 3/10 plus 3/5. So let's look at this fraction and look at the denominators, and you need to find, well, let's look at the smaller number. Can 5 go into 10 evenly? Yeah, it can. So we can make 5 the fifths into tenths. How do I do that? Well, let's list out our multiples. 5, 10. How many times does 5 go into 10? 1, 2. So we're going to take my 3/5, multiply it by my 2 halves, because that's what I'm doing. I'm doing the 2 multiples, and I have 3 times 2 is 6. 5 times 2 is 10. 3/5 is the same as 6/10. We've done this all the way back at lesson like 7 and 8. So now I can add it. I can do 3/10 plus 6/10, and it gives me 9/10. There's my answer. So 3/10 plus 3/5, you convert the 3/5 into 6/10. They're the same. They're worth the same. They're an equivalent fraction, and now I can add them. Okay, so it's 9/10. Does everybody see that? Feel free to email me if you're having trouble with this, and I can set up a Zoom session with you, and we can work on it one-on-one. Okay? Or I can do a small group Zoom session if you guys are having a tough time with it. So let's do the same thing for F. You have 2/3. And I want to add 2/9. Well, the numerators are the same, but the denominators are different. Would you rather have 2/3 of a whole pizza to take home to your family, because that's big, or would you rather have 2/9 to take home to your family and share? Think about it. 2/3 is way bigger than 2/9. Well, how many times bigger? Can 3 go into 9 evenly? Yeah. Makes it really simple. List out your 3's until you hit 9. 3, 6, 9. 1, 2, 3. That means we're going to multiply by 3. 2/3 times 3/3, because whatever you do to the top, you got to do to the bottom, equals, what's this equivalent fraction? 2 times 3 is 6. 3 times 3 is 9. So now you're just doing 6/9 plus 2/9, and you get 8/9. Okay? Watch this as many times as you need to get fluent with it, and just you can make up your own. Okay? Now, they're not always going to go into each other that easily, and I'll go over that in a further lesson when we get down the road, and I'll show you what you do when that happens. Okay? That's all I have time for today for lessons 19 and 20. I think I went over the basics to the point that it made it really easy. On the back, it talks about a number line. I'm going to give you the choice whether to use a number line or a area model for here. I know a lot of kids, I remember from last year and the year before that, they really struggled with the number line for this and it wasn't helpful. So if you're finding that it's not helpful for you, don't do it. All you need to really know how to do in this lesson, the goal is that you're able to take those denominators and make equivalent fractions so that you're able to add them. Okay? That's the goal of this lesson, is that you can see that if you look at B, that 1/2 is equivalent to how many tenths? Well, you should just know that. How much is 1/2 in tenths? What can you multiply that to get to 10? So think about that, okay, as you're going on. That's the goal of this lesson. So if the number lines are really confusing you, don't do them. It's not that important that you're understanding. That's just a strategy to help you. So if it's not helpful for you, don't use it. If it is helpful for you, fantastic, use it. So I do want you practicing using an area model or a number line when you get to that back page, whichever one's easier for you. And I definitely want you doing what I just showed you on the whiteboard, where you're multiplying to make them into common denominators, okay? Any questions, please feel free to contact me through Dojo, Google Classroom, or my email so that I can set up a Zoom lesson with you guys and work with you in a small group, all right? All right, guys, have a great day.